So, when we talk about hardware implementation of a signal processing system, the simplest and most straightforward is going to be, this is the external world, analog signal comes into an A to D converter or some kind of data converter in general, right. Why I am saying data converter is because it might be a camera, it might be something else which is not normally what you would think of as an analog to digital converter. All that is doing is taking some real world signal and converting it into data that can then be processed, digital data. This is going to be your computational module, and the output of that computational module eventually goes into the opposite. It takes your digital data and converts it back into something that can be used in the analog world. It might be a control signal for how much to accelerate electric car, right, or how fast a fan should turn, or how quickly a robot should move, or just basically how much should you amplify a signal in order to decode it or demodulate it correctly, any of those things, right. This is once again going back to the external world. But in practice, and in fact in the systems that we are going to be working with, very often rather than worrying about this external world, we already have the data stored somewhere, either in the memory of a computer or on a file somewhere in a file system of a computer or somewhere else. It is essentially already available to you as data, so you do not need to worry about how the data came. What is important is, in such a situation, it often, one way by which you can look at it is, you already have the data available to you, you are going to essentially put this through some kind of a CPU plus memory processing system, right, which once again gives out data which could be stored in memory or in a file, and finally pushing it out to the external world is somebody else's problem. You are not worried about that. Okay. So, the question becomes, what does this CPU plus memory system look like, and if I find that it is not working fast enough for me, how do I augment it, how do I improve it so that it can actually do the work that I need. Okay. So, for that we need to understand a little bit more about the layout and structure of a CPU plus memory system, right. Essentially the core idea is very simple. There is something called a CPU, central processing unit. The processor core essentially consists of some standard items which you are familiar with. There is an arithmetic and logic unit, there will be some register file, there will be an instruction fetch unit and a program counter that gets instructions from somewhere, right. So, in other words, there will be some kind of a program memory from which the CPU is getting instructions. It will have its own internal register file, etc., right, with which it communicates, okay. And all of this I am essentially going to black box it out and say, this is just one unit out here. What is important is, this unit is then able to communicate with an external block of a large chunk of memory. How does this happen? It communicates by means of something called a bus, right, and that bus essentially consists of a set of signals. There is something called an address bus, which basically tells me where in the memory I am pointing to, okay, and there is a data bus which says the actual content, right. So, the address bus tells you the location in memory that you are trying to access. The data bus has the content. You are either trying to write something into that location in memory or you are trying to read something from it, okay. And any program, ultimately if you look at it, any variable that you declare, right, int I in a C program becomes some location in memory where some data is stored. You can increment it, you can add something to it, you can check the value what it is, you can compare it against something else, but it is ultimately stored somewhere, right. If it is not something very small like a counter for a loop, then it usually goes into the actual memory. If it is something very small, the compiler may optimize it out and just sort of keep it in register files and never allocate memory for it, okay. But ultimately this is what a computer system looks like. There is a CPU with its own program memory, its own register file, ALU, etc., which communicates through a bus with an external memory unit. What that means is, in that memory unit, I can store arrays of data, and I can then read those arrays, do some processing with them, write the data back somewhere else, and so on. Okay? What we are going to do next is understand a little bit more about what is the implication of this bus, what does it mean to have a bus of this sort, what kind of memory can I access with a given bus, and instead of memory, if I want to access something else, or if I want to talk to someone else, some other module that I am creating, how do I use the same kind of bus structure in order to accomplish that.